Hello and welcome to the start of a series of tutorials where I will be showing you how to do some regression modeling in Python. What we're going to do is start with the theory, and we're going to start with an overall theory of what regression modeling is, and then what will happen is I'll then do a part one of a specific type of regression modeling, and then the part two will be doing it in Python. And by the end of this, you should have a really great idea of what regression modeling is and how to use it and implement it in Python. I have realized that over the last couple of months that my YouTube channel is not really geared towards sort of analyst sort of type stuff like data and analytics. So hopefully this will put us back on track, and we'll continue to do lots of really fun non-data like tutorials with coding and programming and stuff, but we'll also, what I'm going to do is implement some more analytical stuff and educational stuff as well. And this will form a start of a really great mixture and cocktail of both those types of tutorials. So let's get started. What is regression modeling? Well, it's a predictive modeling technique that investigates the relationship between dependent and independent variables. So that may seem like a bit of a headache to begin with. So let's break down this statement above, and hopefully by the end of this page you'll understand what that top statement means in a bit more detail. So let's start at the back and look at variable. So a variable is another way of saying a factor which affects something. So the example here we've got is sales, and what affects sales? I've listed a few factors that could affect sales in a business. For example, the number of buyers, the sales team size, the locations of the sales, and the value of the product that you're selling. And each one of these sort of factors can be called a variable. And so what we have with these variables, we have two different types. We have dependent and independent variables. A dependent variable is the variable that you are trying to understand and predict. And this leads nicely onto what independent variable is, and what they are is these are the other factors that you would want to change to affect this dependent variable. So what you can do is you can start to break down these variables here into dependent and independent variables. So here you have sales, which is the variable you're trying to understand and predict, and that becomes your dependent variable, and the other factors which affects the dependent variable here of sales become your independent variables. So number of buyers, sales team size, location, and product value, just to name a few. And what regression modeling can do is you can use it to help further understand the relationship between these two variables, and use this relationship to try and predict what this dependent variable will be in the future. So why use regression modeling? So regression modeling is a really great way, and it's actually can be a very accurate way of predicting the future behavior of a variable when taking into account specific other variables. Now this is a very generic sort of example of why to use regression modeling, essentially to predict future behavior. But it can also be used to estimate the impacts of one variable has on another. So you may not even care about sort of the values that you get in the future. And so at the time factor of the future doesn't really play as much of a part. And what happens is you use calculations and math to plot these points, and then you use those points to draw a resulting line of best fit. And then this line of best fit can show whether there is either positive correlation a negative correlation or no correlation. And correlation this way is another way for a pattern. So the graph you see below is examples of very simple examples of those three different types of correlations. You have positive on the left, negative in the middle, or no correlation on the right. No correlation means you can't even draw a line of best fit. And this is only a summarizing of three different types of correlations, but some people also like to break this down even more and have sort of a very positive correlation where it's very steep, or you have a very slightly positive correlation where it's pretty much like nearing towards like a horizontal line, or you have the same sort of negative on the negative side, and then sort of simple no correlation, or they also say zero correlation as well. All in all, I would say there are 7 main types of regression modeling at the time of making this video. I would say really there's actually probably 3 in that list, 3 main ones, and then there's sort of 4 others which utilize the other 3 to help make it more accurate, and it's more of like a technique to make the results better. So these 7 main types are linear regression, logistic regression, polynomial regression, stepwise regression, ridge regression, lasso regression, and elastic net regression. So this tutorial series will focus mainly on linear regression, logistic regression, and polynomial regression. However, in this video, I will mention briefly what the other 4 are. However, I won't really go into them in any more detail other than mentioning what they are and roughly a very, very high level comment on how you may want to use them. So linear regression. So linear regression is probably the simplest type of regression model, and it assumes that there is a straight line of best fit. As you can see on the right, it's a straight line. And you assume that these points are pretty much a direct correlation with each other. This is calculated by using the equation y equals a plus bx. So y is the sort of, the value y is here, you see on the y-axis, x is the value on the x-axis, and a plus b is where it gets very interesting. So a is the y-intercept. So in other words, you see that red line? That red line will definitely cross the y-axis when x is 0, and when that happens, that is the value of a. So a is the y value when x is 0. And b is the slope or gradient of the line. Now, in very, very simple terms, this can be calculated by treating that red line as the hypotenuse, and then you can use trigonometry to calculate its slope and gradient. However, realistically, it is a bit more complex than that. And we'll go into this in a lot more detail in the next tutorial on linear regression. So for each of the 3 main types of regression that I'm going to go through, we'll have a part 1 of theory and part 2 where we just model it in Python. The next one to talk about is polynomial regression. Now this assumes there's a curved line of best fit, unlike linear regression, which assumed that there was a straight line of best fit. Now these lines of best fit are easier to see than you think, so don't worry if you think that it's going to be curved when actually it's straight, or the other way around. And this can be calculated by using the formula y equals a plus b1x plus b2x squared plus b3x cubed, and so on and so forth, where x is a variable each time, and a is the y-intercept again, where the y value when x is 0. And this assumes a curved line of best fit. Notice here that unlike the continuous gradient we have in the linear regression, we have a continuously changing sort of gradient because it's a curve. And so this is where you have to take your gradient points, pick them very carefully and have, your steps between the gradients. Maybe you want to have small steps where you're taking the gradient calculation from. But don't worry, I will go into this in a lot more detail when it comes up to the theory part of the polynomial regression tutorial. So the final part of where we will continue to go into this in a lot more detail, the final method is logistic regression. And this is used when we assume that there is an S sort of curve behavior. And the best example I can think of, may be very boring for you, but I did civil engineering at university, and the S curve was very apparent when you look at a concrete and how it dries. It dries in sort of an S curve type behavior. And do not despair if you look at the formula you're seeing on the left and you're thinking, oh no, I don't understand any of that. Don't worry, I will go over this thoroughly when it comes to the theory part. But essentially, what we can do is we can calculate a probability, in this case between 0 and 1, using logistic regression. And this equation can be written in different ways, but don't worry, we're going to go over this in lots and lots of detail when we come up to it, when it comes around to it. Also notice that the gradient is continuously changing. And also that the y-intercept could be 0 as well. So moving on, the next 4 sort of methods are sort of more ways of utilizing the first 3 that we've gone through, but to make it more accurate or to sort of emphasize behaviors within variables. So the first one of these is stepwise regression. And these are a series of regression models performed in steps with specific variables added or eliminated at each step. It's essentially like creating a process of the top 3. So you may want to do a linear regression model for, say, a dependent variable with a couple of independent variables, which then moves on to a linear regression of a different dependent variable or the same dependent variable with different independent variables. And then what you can do is you can create like a sort of process where you have multiple regression models sort of happening one after the other with maybe a feedback loop and things like that. And great examples of softwares which do this are Unistat or SPC. And they can both be utilized using Excel actually. And it's really great for automation of regression models. Another example is ridge regression. And this is the analysis of multiple regressions that is particularly used when there is multicollinearity, I struggle to say that word, in linear regressions. So it's analysis of multiple regressions that is particularly used when there is multicollinearity in linear regressions. And so multicollinearity is where 2 variables in a multi-regression model are highly correlated. So below, in the graph below, you see a multi-regression model, i.e. multiple regressions have been performed, and I pay particular attention to the bottom left table and the bottom middle table where they show 2 graphs which are very, very similar to each other. And these 2 variables show what we call multicollinearity. They are highly correlated with each other. This is an intermediate and advanced, bordering on probably maybe is advanced technique. So as mentioned right at the beginning, I'm only going to do a really high level view of what they are. However, my main focus will be on a linear regression, the polynomial regression, and the logistic regression. So another one to be aware of is lasso regression. Now this is a type of linear regression that uses shrinkage. And what you can do now is you can sort of have the data shrunk only a little bit though, only a little bit to a central point. And it's better to use it with models that have fewer variables. And this is a very advanced technique, and so this is probably the last you're going to hear of lasso regression in this series. However, I may do something later on these more complex techniques. And then the final one to be aware of is called elastic net regression. And I'm never quite sure whether it's elastic net as one word, or is it two words, or is it hyphenated. Anyway, it is a technique to combine both lasso and ridge regression models to get a more accurate technique. And this is a very advanced technique because basically what you have is a lasso regression model, and ridge regression models sometimes they can produce quite sort of differing lines of best fit. And what you can do is the elastic net regression provides sort of a very nice sort of in-between line of best fit for both of these lasso and ridge regression models. However, those are advanced techniques, and we're just going to be focusing on the top three. So what happens next is we're going to go over the theory part of linear regression, and then in the next video after that, we're going to model it in Python using a really great module called sklearn, and it's perfect for this sort of thing. And then after we've done the parts 1 and 2 of linear regression, we can then focus on polynomial regression again with parts 1 and 2, and then logistic regression parts 1 and 2. And if you know about the theory, then just wait for part 2. It will definitely come along, and that's why I've separated them, because I'm sure many of you already know about the theory. You just want to know how to model it in Python. So I've separated them out so that you don't have to sort of scrub through and scroll through trying to find where to start. Just made it really easy. Just part 1, part 2. Cool. So thank you very much for watching. Please do follow me on here. Please do share it to someone else who you feel may benefit from this, especially if they do lots of analytics. They may really like it and appreciate it. Please do share my videos. Feel free to embed them in your websites if you have websites and you're watching it. Yeah, subscribe, follow, like, comment as well. Please do comment. I do get a lot of comments, and I try and answer them all. However, I get a lot now, and feel free to comment on other people's comments if you know the answer and I haven't got back to them yet. So thanks very much for watching, and please keep watching my videos, and I'll see you in the next one.